In the last presentation, we examined the anatomy of the skeletal muscle and its connection to the nervous system. In this presentation, I want to talk a little bit more about function, about how the skeletal muscle functions at the cellular level, how we actually get these proteins to grab onto one another and pull, and then also talk a little bit more macroscopically about how we can initiate muscle contractions and how we can kind of grade the strength of contractions. We finished the last presentation looking at the nervous system and how it innervates and connects to a muscle fiber. So again, each muscle fiber is innervated by an alpha motor neuron. We said that in the previous presentation. What I didn't tell you in the previous presentation, not that I was trying to hide anything from you, but again was that, any one skeletal muscle fiber is innervated by one motor neuron. However, each motor neuron typically innervates either several muscle fibers or several thousand muscle fibers. So what we see in this picture here is an example of the concept called a motor unit. You've probably been exposed to this before, but it basically does simplify things for the central nervous system a little bit and allows for us to grade or control the strength of contractions. Like, we don't have to contract our entire biceps all at once. We can contract parts of it, and that's because of the presence of these motor units. So what is a motor unit? I really do want you to understand this concept. My background and my interest area really is movement control, and to understand that, you really have to understand the nervous system and how it connects to the muscles. So a motor unit, okay, the motor unit is one motor neuron, only one, okay? So one motor neuron and all of the muscle fibers that it innervates. So one motor neuron and all of the muscle fibers it innervates. If we look at this motor neuron right here in this picture, we can see that it goes to goes to this one, 2, 3, 4. It goes to 4 muscle fibers out of the 4, 5, 6, 7, 8, 9, 10, 11, 12 muscle fibers in this muscle. So this muscle has 12 muscle fibers. 4 of them are innervated by this motor neuron. The other muscle fibers would be innervated by some other motor neuron. Maybe one other motor neuron, maybe several other motor neurons. But this motor unit consists of one motor neuron and 4 muscle fibers. This allows us to contract a portion of this muscle as a whole. So we can contract basically 4 of the 12 fibers in this muscle if we want to. That allows us to contract some of the muscle, but not all of it. So the concept of a motor neuron, make sure you know it, of a motor unit. It's one motor neuron and all of the fibers it goes to. Now, most muscles aren't this simple. They don't have 12 muscle fibers. They have thousands or tens of thousands or hundreds of thousands. In that case, we often will see motor units of varying sizes. So if we were to take a look at the quadriceps, for instance, that's 4 muscles. If we were to look at the rectus femoris, for instance, the rectus femoris is a powerful muscle. It controls, crosses the knee, crosses the hip. It allows for very powerful, forceful movements. It's a big muscle, so it has, again, probably hundreds of thousands of muscle fibers within it. In that muscle, we don't need to control small amounts of muscle fibers independently. We need to control large numbers of muscle fibers. So in a muscle like the rectus femoris, a motor unit will include one motor neuron and maybe 1,000 muscle fibers. So when a signal comes down that neuron, it will cause 1,000 muscle fibers to contract at once, which yields a fairly significant force production, force output. In muscles like the small muscles that control eye movement or some of the small muscles in our hands, we see much smaller motor units. We see motor units on the scale of 1 motor neuron to maybe 3 or 4 muscle fibers. Because again, if we're trying to position our eye accurately, it does not take a lot of force to move the eye. And we also want to be able to position it very accurately, which needs very small, precise amounts of force. So again, the motor unit is the concept of how we control individual muscle fibers, and we do this with either a motor neuron, and they are working in a group or in synchrony. Now, if I want to contract my entire quad all at once, or if I want to contract this entire muscle that you see in this picture all at once. I can do so. I do it by activating all of the motor neurons that go to that muscle, and I'll get a maximal, very forceful, very quick contraction. So again, this size variation in motor units, again, bigger and smaller motor units, allows for fine and gross force production. Like I said, in a muscle like the gastroc or the rectus femoris, we have very large motor units because we don't need to control the amount of force that we produce very exactly, but we do need to produce force quickly. And then again, we have other muscles where we have very small motor units. Motor units work in the all or none principle, meaning if a signal comes down this motor neuron, it's going to go to all of those fibers, and all 4 of those fibers will contract. They'll respond to that stimulus by contracting. So again, it's all or none. Either the muscle fibers, a signal comes down and they contract, or a signal comes down, or no signal comes down and nothing happens. So this motor unit can't control only 2 of the muscle fibers it goes to. It always controls all 4. The Henneman size principle has to do with the way your body recruits different motor units. Again, remember, you may have thousands of motor units, thousands of motor neurons going to a muscle. Your body doesn't activate them all at once, typically, unless you have to produce a very dramatic force. Generally, you recruit some of those motor units, then as they start to fatigue, you turn some off, and then you turn other motor units on. Generally, the size principle is that we recruit small motor units first, and then large motor units. That somewhat explains what happens when you get fatigued. You can't produce forces accurately, and that's because you've fatigued your small motor units, the ones that help you accurately control force, and now are relying mostly on these larger motor units, which aren't as good at, again, controlling the level of force that they're producing because they're larger. You also tend to recruit slow twitch fibers, again, motor units that include slow twitch fibers first, and then fast twitch fibers later. So again, and we'll talk more about slow and fast twitch fibers later in this presentation. But again, motor units are a way for us to grade or control the amount of force produced by a particular muscle. And again, this is how we recruit different size motor units. So let's look at a hypothetical example to just review this one last time. Let's say you have a muscle that is composed of 1,000 muscle fibers. So this is a skeletal muscle with 1,000 muscle fibers. And it has 4 motor units. That means there are 4 motor neurons, alpha motor neurons, going to this muscle. One of these motor neurons innervates 50 fibers, one innervates 150 fibers, one innervates 300 fibers, and one with 500 fibers. So if I did my math right, that's 1,000 total fibers, and this is how they're innervated. Now again, each fiber is only innervated by 1 neuron. So if I have a task that I want to perform utilizing this muscle, and I only need to produce a small amount of force, I can recruit, the 50 fiber motor unit because it's going to produce a small amount of force. Well, if that's not enough force, I then would recruit the next muscle fiber, or next motor unit, which is 150 fibers. If that's too much force, I can kind of turn this one off and rely on this 150. There's a lot of ways to control force, which we'll see here later, which isn't just the size of the motor units. And generally, we do recruit the small motor units first, followed by the larger motor units. If I'm being chased by a lion suddenly and I need to run as fast as I can recruit all of these muscle fibers potentially and utilize that to generate force. Also, again, as motor units fatigue, as some of the muscle fibers begin to fatigue, those motor units will shut off and they can be replaced by these other motor units. Now, we don't control force just by deciding which motor unit to use. We also change how quickly these motor units turn on and off, which we'll talk about in a future presentation. But again, I just wanted to review how a muscle may be structured and how these motor units may be spread throughout these muscles. Generally, they are spread throughout. So these 50 fibers that are all from one motor unit are not typically all right next to one another. They tend to be spread throughout the muscle, or at least an area of the muscle. and therefore, they're not just all located right next to one another.